All right, welcome to the first presentation of Unit 2. You are halfway through the course, so congratulations. You're on your way to being done. So we're going to be talking this trimester or this unit about decolonizing mathematics, okay, and how white history has sort of tied in with math throughout our studies and throughout history. So have you ever sat in a math class and wondered who invented something, whatever you were studying, and where it came from? Like why we have to solve problems in a particular way to get the right answer instead of another way. Well, the thing is, we often teach math as this is just how it is, just do it and you'll get the answer. And it's kind of a bad answer, but the truth is, no one taught us the why, they just teach us the how. So the why isn't actually complicated, it's just hidden or in many cases lost. This is because the people that discovered or developed the foundations of math have been forgotten. Some of it has been by time because many of the discoveries are ancient, they're prehistoric, they're before we have written record, or even that written record has just degraded so much that we can't read it anymore, we can't understand it. But colonialism has also played a really big part in that. And genocide of cultures has also destroyed some of our history of mathematics. So, colonialism affected education and how we teach history, science, and literature. For example, most colonized countries still teach in European languages like English, French, and Spanish because they were colonized by the English, French, or Spanish almost like 400 years ago, and we still teach using their languages. Because we're always learning things in English, our education system focuses on materials created in Europe or by English speaking countries. Okay? So think about it. Would a mathematician in Kenya, Africa, write their ideas down in English or Swahili, which is the national language? And if their ideas were in Swahili and posted online, would you be able to read it? Probably not, right? If it was translated, you could probably read it, but how many people are going to bother translating a paper on math from Swahili to English? But if this was the same case and the mathematician was German and wrote it in German, what do you think would happen? It'd probably be easier to translate because more people in the Western world who know English and study English or like have learned English and are mathematicians in English are likely to translate something from German to English than Kenyan people from Africa translating something in Swahili to English. Okay? Today, it's much easier to hire a translator or run a doc through Google Translate to understand it. But pre-20th century, however, the Europeans had to rely on information they could read or easily translate. Same with Americans, and so that's why a lot of our documentation tends to be in English because that's the language that people understood, or the people that created your textbooks and the people that teach your classes in schools in the United States understood. Okay. Also, most traditional math education is represented by white males, okay? Like ignoring the Asians here because the Asians are another particular group. Notice that the in the light blue section, the white people, they tend to have higher overall math SAT scores, okay? And then comes Latino and then comes black students. And black and Latino students actually tend to get left behind when it comes to math scores in when they were basing it off of the SAT. Now, a lot of the time in education, we study stuff about the Greeks and the Romans, but we don't study as much information about the Chinese or the Mayans. Okay, that's because the face of math is white men, and women and people of color are often excluded from that conversation. And it's not just math, but it's also science and history as well. So, oops, sorry. Racism is one other big thing that has, basically perpetuated this white centric mathematics. Because a lot of Europeans believed that indigenous people were savages, and they took what they learned, what they learned from like they studied other cultures, and when they saw that the other cultures had all this math, they took all that information and they named it after somebody who was European or Greek or Roman or white, basically, and then destroyed the records of the indigenous people and kind of claimed it as their own. So basically, they stole a lot of work when they were colonizing the world, you know. And archaeology has helped us get some of it back, but racism has also played a part. And it's not just Europeans; white Americans did it when they met the indigenous people of North America. So it's a thing that's happened many many times. So I want to talk about ancient ancient cultures that did study math and what they discovered. So the first group I want to talk about is ancient Mesopotamia. So they were located in what is now modern day Iraq. So it was in the Middle East. Mesopotamia was home to the Sumerians. Okay, this was the birthplace of writing, agriculture, the wheel, irrigation, and a lot of other tools. And they existed from 4000 BCE to 2000 BCE. So this is year 2000 CE, or Common Era. Then they started about 6,000 years ago, and they died out about 4,000 years ago. Okay, so it's sort of like zero CE is like birth of Christ kind of thing. That's when we sort of judge the start or the end of the current era. Because again, it was a Christian system that was passed along with colonialism. So 0 to 2000 is our current period, and before that is BCE. So just so you understand what that means. Lots of people began living near each other in ancient Mesopotamia at the time, and they needed to measure things like plots of land. They needed to tax people. They needed to do all that kind of stuff. So they also needed to chart the night sky and develop a lunar calendar. So the Sumerians developed a base 16 number system to deal with large numbers, like the distance between the sun and the moon and that kind of stuff. Now, after the Sumerians died out, the Babylonians came along. They lived in the same region. So they lived from 1895 BCE to 600 BCE. So again, that's about 4,000 years ago, roughly, to 2,600 years ago. They created something called a circle placeholder for 0. They used Dyson games. They created backgammon. And they also created these clay tablets that you see in the pictures here. And on those clay tablets, we found a complicated metric system with multiplication, division, square roots and squares, cubic roots, and basic geometry. Now, in ancient Mesopotamia, we also discovered what we call the Plimpton 322 clay tablet, okay, named after a European who found it. But this was produced in about 1800 BCE, so almost 4,000 years ago. And it shows that the ancient Mesopotamians, the Babylonians, they knew about the right triangle. And this was centuries before the Greek Pythagoras, who was later attributed to it. And this tablet right here, it lists the theorem, the right triangle theorem, and 15 perfect right triangles with whole number sides. Okay, now some people say that that's just a coincidence, but I'm like, they listed 15 perfect right triangles. That's not super, super easy. So I think they probably knew about it. The next group I want to talk about are the Egyptians. So the ancient Egyptians obviously lived in Egypt, which was in Africa, and this was from 3100 BCE to 30 BCE. So roughly 5,000 years ago to 2,300 years ago or so. Okay, or I guess was it 2,040 years ago technically now. The ancient Egyptians, however, started settling the Nile Valley about 6,000 BCE. So that was 8,000 years ago. They recorded things like the lunar phases and the moon phases, the seasons. They measured using their body parts, and they developed a number system, a decimal system, based on our 10 fingers. Okay, so that's what we call a base 10 decimal system. All right. Now, they developed their own arithmetic, like multiplication and division. They did geometry, fractions, prime numbers, linear equations, quadratic equations, and arithmetic and geometric series. Okay, so or like the pattern of how like numbers in sequence go when the numbers are have the similar differences. Anyway, it's a whole thing. I can explain it later if you have questions. Um, they use the binary system, which is basically counting things by 2, 4, and 8, like it's doubling it every time. And they used it 3,000 years before the Europeans found it and started using it. The Egyptians developed math to deal with agriculture, city planning, taxation, and in their business systems like trade and some, money, markets, and all that kind of stuff. They used their geometry skills to build the pyramids in 2500 BCE. Okay, so those are structures that exist almost 5,000 years later. Like they built things that lasted 5,000 years. That's crazy. Okay, the ancient Mayans lived in Central America from 2000 BCE until 1517 CE. So they lasted 3,517 years until the Spanish conquistadors first arrived. And unfortunately, because the Spanish conquistadors brought like smallpox and influenza and all those diseases, and then conquered them and killed a bunch of people, by 1541, 90% of their population was dead from disease and war, and the remaining 10% were conquered by the conquistadors. And they were pretty much wiped out by 1600s. Um, as a result, much of what they discovered is lost, unfortunately. And what they discovered really has not had any influence on European and Asian systems because the conquistadors, like when they went there, they found some stuff, but they didn't really understand it and they didn't care and they thought that they were savages. So they just took their stuff and left, and they didn't give them any credit and none of their mathematical discoveries went to Europe or Asia or anything like that. They were just lost, you know. So the Mayans developed a base 20 number system that included a circle symbol for zero. Okay. Their astronomical observations were super accurate, like it was crazy. And it was even more amazing because they used sticks for instruments. Like that's all that they used. Sticks and their eyes. And they were able to measure things like almost as good as we can today with like mathematical tools and all kinds of fancy gadgets. They were able to measure their solar year as 365.242 days. And in comparison, the modern day value is 365.242198. So literally, they got the same exact number as people did 3,000 years later with fancy instruments. Okay, that's crazy to me. And their lunar month they calculated to 29.5308 days, which is so close to what we have, which is 29.53059. They were literally off by 0.004. That or 0.003, sorry. Actually 0.002, because if you round up the 5, that becomes a 6. They were super close, right? So, and by the way, this right here on the right, this is their number system. So they use dots to represent like 1, and then they used a bar to represent 5. So it actually made a really easy counting system. So let's talk about the ancient Chinese. We find the earliest traces of ancient China as far back as 2000 BCE, so about 4,000 years ago. And it's actually one of the few countries to never be taken over by white colonists. The Qing dynasty ended in 1912 and it became the Republic of China. And then the Republic of China became the People's Republic of China and it became communist in 1949. The ancient Chinese developed the first decimal system in 2000 BCE using bamboo rods. And this is the same system we use today and was adopted by the Chinese 1,000 years before the Europeans. So 4,000 years ago, they developed this system, and it's stuff we still use today. They created Sudoku, like magic squares is what they called it right here. It was just a way of playing with numbers. They also developed mathematics because they needed it for civil service, and they solved equations using a matrix-based system that was called Gaussian elimination after the European guy who then discovered it in the 1800s. So they invented something thousands of years before a European guy, but the European guy gets all the credit because he discovered it and the Europeans named it after him. So if you see that name in any kind of future math studies, know that the Chinese came up with it first. Liu Hui was one of the greatest Chinese mathematicians, and he lived in 263 CE, or about 1800 years ago. He calculated pi accurately up to 5 spaces. He developed early forms of integral and differential calculus, which is like the highest level math that usually high school students can learn if they want to. And he left roots as they were to give more accurate results, which is now something that people use all the time, but he was one of the first people to do that. Okay, so I'm going to go ahead and stop the video because I'm running out of time limit for my screencast software. Go ahead and you can take a break and then come back and watch the remaining part of the video to get the last couple of slides, okay? Thanks.